feel like we're in the Bahamas whenever I hear this. And
hello and welcome to World's End Project. I'm Shelley Carney.
And I'm Toby Younis. Thanks for joining us today. We have a sample to show you from the East Coast this time. And it's a very special collector. So we're going to talk about that. We also have some emails to read. I want to talk about our prize giveaway for just a second, because we do have a prize giveaway coming up. And we're going to introduce you to the newest member of our little team. The ME580 PZ2L polarizing microscope. Just join the team. Okay? Stay with us. It's going to be a lot of fun.
And we're back.
How are you doing, Miss Shelley?
Super. How are you doing?
I'm doing okay. Let me talk about giveaway first. So when we're at about 60 subscribers right now. When we reach 100 subscribers, actually we're going to give away one or the other of these books at 100 subscribers, and then we'll give the other way at 200 subscribers. In order to qualify, you have to go to last Friday's show. I don't remember the date. Can you do
5th.
Friday? Yeah, last Friday.
Friday was the 5th.
So go back to the show from Friday the 5th and make a comment, because when we reach 100 subscribers, we'll draw. We'll give everybody a chance to make sure that everybody's aware, and we'll draw, and you'll get one or the other, your choice of one or the other of these books, and then we'll give the other one away when we reach 200 subscribers, and we'll just keep doing giveaways. There was something else. So I told you about the new microscope, and you'll get a chance to see it today. We got a lot to do in our 45 minutes, so I'm going to get straight to it. So you want to read our emails? Oh, you're right. I forgot it.
Housekeeping, you want towels?
Of course, you want towels.
You need towels at the beach.
And you also need to wash them at least once a week. Otherwise, they just
full of sand fleas.
We'll wash them under the microscope.
Sand fleas.
Make sure that you take a moment to like our video. YouTube likes it when you like our video, and there are the other people in the world who like it when you like our video. Share it with your family, your friends, your neighbors, your business associates, the entirety of your social networks so that we can
grow the channel.
And then finally, if you're not already a subscriber, this would be an ideal time to subscribe. After you watch this show, you're going to want to subscribe because this is going to be about learning. And once you subscribe, make sure you click on that notifications bell. That way, when we schedule a live stream or we launch a live stream, you will be informed and
in the know.
In the know. And there's nothing better in life than being in the know.
And having clean towels.
That's right.
And growing.
So I'm going to have Shelley read a couple of emails that we received from our friends, and then I'll tell you about the sample, and we'll go straight to the photos.
All right. This is from Michael Hool, one of our friends. And it says, sample from Australia. Hi, hello, Toby and Shelley. Yesterday I sent a sand sample to you from Mungo Beach in Myall Lakes National Park, which is in the Australian state of New South Wales, about 200 to 250 kilometers north of Sydney. It was collected on 12/7/2019, just below the shoreline. I had to be quick. I cleaned the sand by rinsing and soaking in tap water, then boiled, microwaved, and dried it.
Wow.
It should arrive before Christmas.
That's a great specimen.
He is like, he's an academic.
He's
so
an academic.
He understands the scientific process.
Yeah.
The spot is one of those mythical, unspoiled South Pacific beaches that stretch as far as you can see in both directions. Check the map. It's an easy day trip from where I used to live in the 90s and is a special place for me. If you credit me in writing, please use meh and not my full name. Uh-oh. See, you got to put those at the beginning.
Okay.
Meh. I prefer that Google searches reveal my work without my hobbies mixed in. Thanks for understanding. Here are the photos. Only the photos showing me are at the actual spot. The others were taken at other locations in the same general area. All the best for the new year.
So, Michael, again, I apologize for using.
Well,
the
he says
current-
in writing. If you credit me in writing,
Oh, okay, all right.
we just
And
said the
then-
words.
Right.
We're good.
And Michael did send some really great photos, and we'll share those with you on the day that we schedule for presenting this sample.
Yeah, that should
Because the
be fun.
photos are really great. It really does look like one of those idyllic South Pacific beaches. So,
Okay. This one is from our friend in the chat room, JK Pioneer. Smoky Mountains Sand Sample. Hi, Toby and Shelley. My name is Jeff, JK Pioneer. I'm not going to read last names.
Last names,
anymore.
yeah,
I don't wanna
I guess we
get in
should.
trouble. And I live out here in beautiful East Tennessee. The Smokies are about a 45-minute drive from the house. The Townsend Y is a popular place during the summer for tubing, swimming, and fishing year-round. This is where the Little River meets the West Prong Little River, and the two combine right after the bridge. The first picture looking down at the rocks and sand is where I took the sample. It looks like I'm going to have to send pictures in batches. I will end this email and send the rest of the pictures. Please let me know if you have any questions. Take care. Keep up the great work you do with all your channels. Peace, Jeff.
Jeff, thank you very much. I noticed you aren't in the room, and he did send, I'm going to guess, around 10 emails with photographs.
Oh.
So we will share those again when we present that sample.
And this is just pictures from
Well, I wanted to say,
the New Jersey Pine Barrens.
this is the New Jersey. This is
New
just
Jersey.
New Jersey Pine Barrens. I just had this as a reminder because this is from our friend Fred, and we're going to be doing the New Jersey Pine Barrens sample this coming Friday. I pushed out the second sample from Washington. I wanted to do some East Coast stuff, and what was interesting about the New Jersey Pine Barrens is this is not a sample that was collected. It's a sample of sand, but it was not collected near water. And we'll talk more about the New Jersey Pine Barrens when we get to that sample. So Fred, on Friday, join us, and maybe you can call in and tell us a little bit more about it. But he too sent some really great pictures. Okay, so today's sample, I'm going to flip over to the window shot. Today's sample comes to us from Delray Beach from the town of Delray in Florida, and it was collected by a young lady, an attractive, intelligent young lady whose name is Erica English. Her maiden name happens to be Erica Younis. She's the fifth of my children, and she's married. She's married to Patty, and Patty Patrick was born and raised in Boca Raton, and they met at the University of Tennessee and married in Boca Raton after they graduated from college. They have one daughter, whose picture you're going to see right now, and we have another one. They have another. I have a grandchild. I'm expecting a new grandchild in March, and I'll go off by 15 to 20 feet, even though it goes to into the decimal digits. The hundreds of decimal digits. But this is kind of an average area for Delray. Nice homes near the beach, condominiums near the beach, and then streets that lead down to what they call Route 1, A1A, Ocean Boulevard. And you can there's parking along Ocean Boulevard. As you go further south, there's actually parking lots and established parks. But they all have these little walkways that you can see right here. We're going to see a picture of those that lead down to the beach. Oh. So it's following me right there. I don't know why it's saying we're offline. What did our
Yeah. Back
okay,
and forth, in
frozen
and out, I
back and
guess.
Huh.
We're in and out.
Okay. So YouTube has been really, really slow recently. I don't know whether you guys have noticed, but as you're just, we have a 1 gigabyte internet here, and I can see that we're pumping out, 5162K baud. But YouTube has been so weird. It takes days to scroll through a page on YouTube anymore. I'm not sure why. Refresh that and let's see what it tells us. Refresh the, Don't know. We'll just keep doing what we're doing and make sure that you know, if nothing else, you guys can come back and watch the video. But what I was saying is this is the A1A that goes right along the beach. I think all of the beaches in Florida are public. I think they made this same kind of rule that they made in California after California Proposition 20 back in early 1970s. So the sand sample was collected right about there, and how come it's not moving forward? Okay, I need to get the arrows. There they are. And this is what it looks like as you're leaving the A1A and headed down towards the beach. There's a lot of foliage along the beach, and they do that to protect the sand from being blown out to sea and having to recover it. This is a day where it was really crowded. One of the days that I visited there about 2 years ago when 2018, Everly was celebrating her first birthday in November, and it was a lot more quiet. It was November, and I got some great shots of the sailboats. They have a sailboat club right along the beach there. So that's what the beach looks like. One of the things that I noticed about this, and Erica mentioned, is that there's a lot of seaweed that's washed up onto shore. And there's people that collect the seaweed and they do something with it. I didn't ask what they did, but evidently there's you can recycle the seaweed into something. But I noticed that there always is a lot of it on the beach. That is granddaughter Everly on the beach, so she's having a good time.
You sure it's not the Morton Salt girl?
She's just so cute. She's very much her mother. I've always said my three daughters are very much beach girls. Their mother started taking them to the beach early, and so they've done the same thing with Everly. So she's a beach baby. But as you can see, surrounding here, of course, is the seaweed that I mentioned earlier. So you get a lot of that. They don't seem to mind it. Here she is making one of her faces. She's always got a bow, and sometimes the bow is bigger than her head. It's something her mother did, and they're always running the boat. But again, they spend a lot of time out there. And she has fun out there entertaining herself. Here's some of the seaweed coming in the afternoon, and you can tell it's afternoon because the sun is behind the camera, and it starts washing that seaweed in. It takes off some of it as the tide goes out, but there's a lot of it there. Another shot out towards the beautiful blue-green Atlantic Ocean. So this was the sample that she sent me. As you can see, it very much looks like a beach sand. It's very fine-grained, and it has a lot of quartz in it. We'll see it in just a moment. I ran the magnet through it like I did with the other samples that we've done, and it literally came up negative. There was no magnetite, no metals in the sand. It was very clean when it came to metals. It didn't pick up anything, as you can see. I thought I'd take a shot just so you could see it. So this is an overall view, and what was exciting about this sample is not only did we see a lot of quartz and a lot of very interesting rocks, I saw my first microshell since we started the show, and I started seeing some more organic objects. These organic objects are called foraminifera. And I'm going to show you more in just a minute. I'm going to tell you a little bit about the foraminifera. And the first time that any of the samples we've received, although we've received other beach samples from the California side, this is the first time that we've seen foraminifera. Or forams. The scientists, I suppose they get tired of calling them foraminifera, and so they refer to them as forams. So we're going to see more of those. This is a little bit closer up on that shell, but again, you see a lot of the polished quartz, some new stones, some oddly shaped things, and those are most likely not organic. They are calcium carbonate. That would make them shells of some kind, colored shells of one kind or another. I saw a lot of polish them. And again, you know, if you were a rock hound, you would collect stones and you'd put them in polishers and in the process. I don't know if you've ever polished rocks or stones, but the process is lengthy. You know, 3 weeks with one grit, 3 weeks with an additional grit, 3 weeks with an additional grit to get the kind of polish that you see on these stones. But these stones have been polished by wave action, by river action, by being washed down from mountains and surviving that trip. And the quartz are the most durable of all of those. So that's why you see so much quartz in sea sand. It's far more likely to survive the trip. But again, some of these more colored ones are probably shells of various kinds, colored shells. So this is a little bit closer up. And I had kind of tapped the sample, and the heavier pieces started moving into the center. Now you got to remember we're talking about grains of sand, but here's a very small stick, a rock that has inclusions of some kind. This, which looks very organic to me, but I have no idea what it is. My first reaction is that it was some kind of like a spine from a what are those spiny things in the bottom? The black urchin, like a sea urchin spine, and a micro shell that has some characteristics of foraminifera. And so there was a lot of different things in there that I wanted to take a look at. Here's an even closer look at that microshell. The holes are actually part of part of the foraminifera. And the reason is they have these spiny legs. I'm going to show them to you in just a minute. They have these legs that go out and capture food. They are single-celled animals. They don't have a long life. They're all over the ocean. Again, I'll tell you more about it in just a second. So there's that. There's a close-up on that one object that looked very organic to me, but it's got kind of a twist to it. It's not your average rock, but I couldn't tell you what it actually is. This is a close-up of that rock with the inclusion in it. Looks like it's quartz with something else in it. And then this is where I saw not only the microshell, but see this right down here and this right here. Those are calcium carbonate shells that were once the homes to these foraminifera. Forams. I'm going to start saying forams so I don't have to remember each time. And I haven't seen these in any of our other samples. This is probably some calcium carbonate that's taken on some pigment because of the holes. But again, for me, it was very exciting because I hadn't seen these in any of our sea shore samples prior to this time.
Bandit wants to know, what is the magnification?
Oh gosh, I didn't record this magnification, Bandit, but I'll be able to show you in just a minute. The magnification on this, well, those are sand grains. They're about the size of salt grains. Oh. So I'll start. It's one thing. I'm gonna go to full frame for just a second so I can show you. So that's a bottle full. That's about 5/10 of 1 pound of sand, little tiny sand grains. So it's beach sand. It's very fine beach sand, and so this is magnified probably 4 or 5 times in this particular case. So this is what I was talking about. This is a living foraminifera, and what's important about them is they make up.
They can't see it.
Oh, I'm sorry. Okay. So what's interesting about them is they make up a significant portion of life in the ocean. But what's even more important about them is that they, while they're alive, they eat things and they turn those things along with chemicals in the water, oxygen in the air, and they use all of that to create a shell of calcium carbonate. Eventually they die and they decompose. They're single-celled animals. They're not, for single-celled animals, they have this wonderful brain that enables them to survive in the sea. And those holes that I showed you before actually were where those spiny legs go out, and they use that to capture their food, and they basically bring their food into them and they disassemble it, they consume it, and that's how they grow, and then they grow these shells. Well, when they die, their bodies decompose and their shells fall to the bottom of the ocean. It turns out that this has been occurring for over 100 million years. That means they were here and living and falling to the bottom of the ocean before the dinosaurs before the dinosaurs became extinct, before the dinosaurs were killed off, which happened about 65 million years ago. So the bottom of the ocean has these layers of foraminifera. It has layers, literally hundreds, if not thousands of feet worth of foraminifera that have fallen to the bottom of the ocean based on age going back 100 million years. Well, what scientists discovered is because of the way they create their shell, they use carbon, calcium from the water, carbon, and oxygen. And they use two kinds of oxygen, light and heavy. Didn't even know there was that there. But because it's stored in their shells, scientists have figured out how to take one of these shells, do a chemical analysis of it and determine the state of the climate. So forams, these little tiny objects that you can barely see with a microscope, have become tremendously important to what are called paleoclimatologists, the people who study our climate into the past, because of the way the forams collect these atoms that they use to create their shells. And so what they do is they have ships that they dig down deep into the ocean. They pull up these tubes of forams, they break them out, and then they start analyzing each of these little tiny objects from the different ages up to 150 million years ago. And so paleoclimatologists have actually made graphs of the Earth's climate back 100 million years, and they're using it as a way to predict what's going to happen based on the amount of carbon that we're producing now, which the forams are recording. They're like little data collectors for us. And they play an amazing role in climate management. And eventually some of those shells, which could be hundreds of years old, if not millions of years old, wash up onto the shore. And what we saw today was the first of those that we've seen in our program. I have, if you look at the playlists on our channel, our WorldsandProject channel, last night I made a playlist on foraminifera. And I strongly recommend you take a look at it. Take a look at a couple of them because they're just amazing. You never could imagine that these little tiny microscopic objects play such a big role in our paleontological science. I'm learning I'm not learning them. I knew they existed. I just never had to use them in front of a camera. Okay, so let's go to okay. So who asked the question about
the magnification? That was Bandit.
Bandit. So Bandit, I'm going to start, and this is I'm going to do this real quick. This is magnification. Let me get it in focus for you. That is magnification 0.7. So that's a grain of sand at 0.7 its normal size, magnified, right? And this is the sample. This is just, so one of the things that I did, I got so excited about the forams that I actually sifted them out because they were larger than the 2 millimeters for the standard sand size, and I have a screen that enables me to take those out. So I sifted them out. So after I show you these real quick, I'm gonna give you some forams, and then I'm gonna switch over to the new polarizing microscope, so you can take a look and see how beautiful the quartz crystals are. Okay, so let's zoom in about halfway and get a better look. I'm going to bring you in just a little bit, and you can see right there on the right side of the screen, right there, there's a calcium carbonate object right there that managed to get through the screen. So, but the rest of it, other than these little organic objects that we haven't seen before, the homes of these various forams, it's pretty much like the other beach sand with a lot of quartz crystals. And as we discussed before, the quartz crystals come from the mountains. In this case, they would be the Smoky Mountains. So those are, and that is 5 times magnification. So you can see there is a variety of rock types and stone types, but I would say that in this case, the majority of them are quartz crystals.
Odin has a question.
Go ahead.
Ever find anything that looks like a cosmic spheral People search like crazy for those stuff, sweeping down their flat rooftops, etc., for the cosmic dust.
Yeah, so there is, as a matter of fact, Verge, the Verge, which is a YouTube channel, just had a short documentary on that microscopic dust, and they use magnets to collect them. I haven't, I wouldn't know one since I haven't really researched it much. I wouldn't know if I had seen one. I mean, I couldn't tell you if I had, but it would be interesting if I were to find it in. They say that we are bombarded, the Earth is bombarded by the equivalent of 60 tons worth of microdust every day. Enough dust to for one of these dust specules, and they're microscopic, to fit into a 1 square meter area. So you can cover the Earth 1 square meter with all these dust particles, these micro meteorites that are falling to Earth. And if you watch The Verge, look for micrometeorites and The Verge. There's a guy in, I think, the Netherlands who's an expert on this. He's actually a guitar player, but he took an interest when he heard about it, and he literally wrote the book on it. And he has images of hundreds of these micro meteorites, and they end up, because they burn in the atmosphere, they all end up kind of marble-like round, but they all have different chemicals in them. So after you guys finish here, search for The Verge micrometeorites, and it's a great story. So this one is interesting, I thought, this little orange object, because it looks at first like it's stone, but then it has those holes in it. The implication being that at some point it might have been a home to one of the forams. So it was just a really interesting specimen. There were some others. I didn't see as much color, and I didn't see as many composites in this sample like we did in the sample from the mountains last week. But again, when you see something like this and you look at it close, your first reaction is that it's a rock. And then you notice there's all kinds of inclusions and intrusions in it that make it more than a rock. So this might have had an organic history to it at some point. So just a lot of quartz, a lot of colored quartz. When it isn't quartz, it isn't colored quartz. But also I noticed that these yellow-orange ones, if you look at them close, they have things inside of them. They're not just quartz. So what I'm going to do now is I'm going to switch over to the sample that I sorted out of the forams, and let's take a look at those. And they're very different from just the grains of sand. So give me a second here, because I'm going to have to zoom out first and then get it in focus. Let's go out as far as we can. So these are all objects that were sifted out of the 2 millimeter screen. That means they're bigger than sand. And as you can see, there is a lot of action. There's lines and there's holes and other things that would imply that these are not just your average grains of rock or quartz, et cetera, et cetera. They have a lot going on. And again, they're bigger. So there is the occasional piece of quartz in there that was just a little bit bigger. But again, what you notice about them is not only their size, but their variety of colors, lines and holes and all kinds of things that imply that there's something other than just,
What's going on with that blue one?
Yeah, that's definitely a shell. Let's zoom in on that a little bit. So that's not something you're going to, no matter how much a rock has traveled from the mountains, that's not something that you're going to find in the rock. So it's more likely a shell, as is that one right there. But those little holes in that shell indicate that at some point it held one of the forams, because those are the holes that it stretches out its little, I say little, like If it was my size, it would eat my face. And then there was some nice, there was a nice piece of olivine in there, and then down there was that. So again, we're just seeing more interesting objects here. The pink object. Let me zoom in just a little bit more. So more interesting objects.
Have you seen any critters in the sand yet?
No. No, they don't survive. I don't think they survive the collection process, because one of the things that you're going to do is, of course, you're going to put them in a bottle and let them sit out. And if
microwave.
Microwave, yeah, like Michael, microwave it to kill everything. And I think that I actually put them out in a window so the sun will dry it, because I've got some samples, and when the samples are wet, like all sand does, it sticks together. So you have to dry it so so that the samples come together. Okay, what I'm going to do is I'm going to go back to full frame right now, because we've got a few minutes left. Well, I do have a few minutes left. So let's take a look and see if we see any other.
Did you look it through the polarizing yet?
Not yet. We're going to. So this was pretty natural, organic, and interesting. I just, it's like, what the heck is that? Got a lot going on right there. So, and it wasn't wood. I checked it out. It's not wood. Let me see if I can find. I want to find that one longer yellowish orange object. Let me see. There it is, right there.
The swirly thing.
Yeah, that's definitely, a shell or something that was organic once, just because of the shapes and things. You're not gonna. That doesn't, erosion doesn't do that kind of.
Because it looks like the other one that you saw too.
Yeah.
So there's more than one.
No. That's actually the same one.
Oh, it's the same one.
Yeah, because when I took the pictures, I realized, wow, there's some really interesting. So that's when I sifted it and put these in a separate little quartz bowl. So just some beautiful stuff, and it's hard to tell because of the polish. You're seeing the ring light, the LED ring light is creating that shine on it, but these objects are all the one just above it, if you look at it, is beautifully polished from being, run in the sand. So very nice. Okay, so I'm going to go back to full screen. I have another camera coming in, so I won't have to do this the next time. But what I've got to do is I'm going to switch the camera over from the stereo microscope to the polarizing microscope.
Toby's doing that. I'll just say hello to the people in the room. We have JK Pioneer and K Pro and Corey Jacobs, Bandit, Bill Cross, Odin, and Britt Chaser. Hey, guys.
All right. So I hope this amazes you as much as it amazed me when I first saw it. So this is the view of that same, it's not the same sample, but it is the same location from the sample through the polarizing microscope. And because it's a polarized light, as it's refracted, and this is a much higher magnification than the stereo microscope, as it's a polarized light, you can see that as the polarized light goes through that quartz, it creates a rainbow of light through the quartz as it bounces off the different facets, because these are rough facets of the quartz, and it creates that beautiful lighted response. So,
almost like ice cubes.
Yeah, exactly.
Crystallized.
So let me go back here and see if we can pull some of that out. So this is a little bit thicker sample. So there's, grains laying upon grains, laying upon grains. And again, I don't see as much color as I did in the sample that we got from Washington, which came from the river. We had blues and reds and greens. This one, mostly quartz. I'll have to say it's mostly quartz. But there are some kind of interesting little objects in the grains that have a very organic look to them. I mean, that obviously to me doesn't look like your average rock, whether it was washed down from the mountains or not. It seems to have something, you know, organic about it, and I wish I knew more about it to be able to describe it. And as I learn, you know, whatever I learn, I'll share with you guys. So as you got to the edge, this one isn't in one of the little quartz bowls, so I've just laid it on the glass. And you can see that once it's on the glass, the reflection from the quartz just gets really amazing and interesting and dramatically, you know, rainbowish. But that's the result of looking at it through the polarized light. So polarized light, I'm not going to get into telling if we'll be here another hour if I start telling you about polarized light. But it gives us a different look, and these are, I'll be making images of these in even higher magnification. I'm going to show you, I'm going to go to, that was 5x, this is 10x, and the issue is that at 10x you start, the depth of field is so small that, this is the hard part. The depth of field is so small that you basically have to walk through the granule of quartz. So, but it really makes it beautiful. And then the highest magnification on the polarizing microscope is 50x. And here's where that's that same grain close up, but again, the depth of field is so great. I actually have to adjust the light. Let me turn the light down just a little bit. Oh, that's interesting. The camera is correcting for it. So that's that same grain of sand at 50x on the polarizing microscope. I'm going to go back to the 5x so that we can get a better view of it. So, yep, I think this was a fun sample for me because, as I said, it was the first sample that produced some of the forams and more than one of the calcium carbonates, the shells. It just had a lot of things going on for it, so I'm looking forward. I do have another couple of samples from Florida that we'll be looking at in the future, and we'll just see what each one of them produces. I'm looking forward to this sample from the New Jersey Pine Barrens next week because it's a very, I feel, I haven't looked at it yet, but I feel like it's going to be more like a desert sand than anything else. It just looks like that to me. Let me see, is there anything else new? I'll take some pictures. I'll take some additional pictures of some of this before the end of the day, and I will post them to the photo album. And the photo album, there's a link to the photo album in the description box below, so you can go to that. And if you want to see some of these pictures, you're, oops, hang on, you're not seeing it. So here we are. So there's a link, a bit.ly link, because the Google Photos link is just longer than the Dickens. There's a bit.ly link to the photo album in the description box below. You'll be able to see some of these photos, and then I will add some others from the there's nothing here from the polarizing. That? Which one? That's the magnet.
Oh,
you were reading the thing. So what was interesting about this particular sample is that when I ran the magnet through it, I didn't get any magnetic response. I didn't get any of the little black magnetite, and I didn't get any iron or anything. It was literally just blank. So I thought I'd put it in here for the record. So if you want to take a look at them, give it a day, and after we get through with our day today, I'll post some of the images from the polarizing microscope so you can see how beautiful that quartz looks under the polarized light. Okay. Dimple. And
Hey, everybody. Thanks for being here today, for sharing your thoughts with us in the chat room. And for World Sand Project, I'm Shelley Carney.
And I'm Toby Younis. Thanks for joining us today. Remember that if you want to send us a sample of sand from your location, there's our address is in the description box below. There's a link to a video that explains how to do it. And make sure you take pictures of the area so that we have to share with folks. We'd love to get sand, a sample of sand from all of you. And of course, some of you that are already in the room have done that. So we're very grateful for that. Thanks for doing that for us. We look forward to doing more of these shows and exploring them. It's certainly giving me an excuse to buy a lot of equipment, so not bad.
So if you're interested in spending more time with us, we're headed over to the softer side. You can follow us over there. We're going to be talking about winter doldrums and
and how to stay out of them.
Yeah, and how to deal with that.
Yeah,
so
exactly.
We'll be over there at 4 o'clock.
Don't get caught up in other people's winter doldrums.
Yeah.
All right?